Markov chains video number 2 for classification of states. So now we're going to talk about recurrence. Now, all of these states communicate. You can get from 0 to 1, you can get from 0 to 3, 0 to 1, you can get to 0 to 1 this way, get from 0 to 2, 0 to 3, 2 to 3, 2 to 1, 2 to 0, and so forth. So if you trace all of them, you can get to each state from each other state. So they all communicate, they're all accessible from each other, and they form a single class. Okay, a Markov chain that forms one class is called irreducible. Turns out that if you reduce the transition matrix, you will get the identity matrix. That's where that goes. But in any case, single class, one class only, it is irreducible. This is an irreducible class, but unless that's its own Markov chain, if it's a part of this, now we have two classes. But if this guy is its own Markov chain, and it's just one, it's kind of a trivial case, one state that always goes back to itself, that is also irreducible. So, but let's just talk about this guy. So, recurrent states, states that once you've left, there is a positive probability that you're coming back to them. So all of these states are recurrent. If you have a transient state, it's not recurrent. Transient states, once you leave, you're not coming back. Recurrent state, once you leave, you're going to come back. So a state is either transient or recurrent. Okay. Also, a class is either transient or recurrent. Okay. So transient, recurrent can be a state property, also a class property. All right. Now we're going to talk about periodicity. So the period of a state is how many steps it will take to get back to itself. So in this case, for example, state 0, there are two ways to go from state 0 to itself. You can either go from state 1, from state 0 to state 1 and back in 2 steps, or you go state 0 to, so this is 1 step, 2 steps, 3 steps, and back to 0, so that would be 4 steps. Okay. To get from state 1 back to itself, it's the same set of numbers. 2 steps to get back to state 1, or you go all the way around and it's 4 steps. To get from state 2 back to itself, you can do it in 4 steps, just go the whole way around. You could also end up taking a loop here, so you go 1, 2, 3, 4, 5, 6, or 2 loops, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. So it turns out that the greatest common denominator, the greatest common divisor of all of these numbers is 2. So the period of this Markov chain is actually 2. In this case, for state 0, the period, it's pretty clear, it's 2 steps to get there and get back. For state 2, the period is, well, it could be 4, it could be 6, it could be 8, but the greatest divisor is 2. So we want to know the greatest divisor for all of the possible numbers of steps it takes to get from one state back to itself.